All right, so today we are going to take a look at how to analyze and improve your Create React App Webpack bundle. So that's going to be fun. Basically, what we're going to do is we're going to create a new React app. We're going to add a big library. We're going to look at different ways of importing it. And we'll look at how to use lazy loading to split the code up into different chunks. And we'll see along the way kind of how each one of those steps affects the final build, and we'll look at it as we go. So let's start by creating a new React app, which I'm going to do here. Zoom in on it. Doesn't want to zoom. Okay. Well, that's all right. Yeah. There we go. Scroll wheel. Let's do So we're calling the Create React App package. We're going to call it Big and Bloated. That's what our project's going to be called. And because I don't do anything without TypeScript, we're going to use the TypeScript template on that, and it'll create the project for us. And while that's going, I'm going to load it up in VS Code. Seems like it's working. Big and Bloated. Still going. There we are. Okay. Let's make that nice and big. So what we have here is the brand new, fresh Create React App project that we just loaded in. So let's make sure that it runs. I'm going to open up my terminal here. I'm going to use it. npm run start, which should run it on a development server. Apparently something's already using port 3000. That's fine. Yes, run it on 3001. And here's our basic app that's ready to go. So without adding any libraries, anything like that, we want to analyze and see how big the chunks are that Webpack is spitting out, and we want to view kind of each module individually. And there's a visualizer tool for Webpack that does that really easily. It's called Webpack Bundle Analyzer. Now, out of the box, you can't configure React App. You can't configure Webpack in React App, but they do make some tools that make it really easy to do. One of them is called Krakow, Create React App Configuration Override, I want to say that it stands for. So we'll need that to edit the Webpack config for a Create React App, and we'll need the Webpack Bundle plugin analyzer as well. So let's grab both of those. So I'm going to run npm install at krakow/krakow across env. Actually, I don't need that. Sorry, got this from somewhere else. Don't need that for this particular setup. So Krakow, Webpack Bundle Analyzer, and we're going to save that as a dev dependency. See how that goes. Okay, so those are installed. So we should just be able to run npx Krakow build instead of React scripts build. So if we run the build that comes with Create React App, if we look at the scripts here, we'll see that the build command is React scripts build, and you could run that with npm run build, but that won't use a custom React configuration file, which we haven't created yet. So actually running Krakow build is not the right thing to do. The first thing we need to do is make our configuration override. So that file goes in the root of your project, and it's called krakow.config.js. It just occurred to me that Krakow could be pronounced Krakow, and that never crossed my mind. So if it's actually called Krakow, then you'll have to put up with me, because I'm going to keep calling it Krakow for now until I know how it's actually pronounced. So krakow.config.js, and it looks a little something like this. We have we're going to import using require. This is just a standard JavaScript config file, so CommonJS imports are good. Require Webpack bundle analyzer .bundle analyzer plugin. We save that in this variable, and then we export a function which has our config overrides for Webpack. And our Webpack plugin we're going to use is a new bundle analyzer plugin, and the analyzer mode is going to be server. And what that means is when we run it, it's going to open up a little server and display the results of our bundle analysis in a nice little interactive HTML web page. And if you don't want to run that server, if you're doing this, say, in production mode and you want to just output a file, then another option you have for this is JSON, and that'll output a JSON file with the analyzing bundle details in it. But we want to take a look at the server for now. So I'm going to save this Krakow configuration, and then I'm going to run npx krakow build. So what that should do is build a production version of your React app and then analyze the production build. And we'll see that by having a build directory that just appears here up in the corner. There's the build directory. Error in use. Oh, I really should have killed this process before I started this. Bear with me for a moment here. It's probably going to kill VS Code too, isn't it? Don't run kill all arbitrarily. I mean, I think it worked, but that's probably not the right thing to do. You can use process tree and find the process code of whatever node app was running on port 3000. Anyway, what was I doing? Oh yeah, Krakow, npx krakow build. There it goes. And here is our bundle analysis. So we have, you can see little edges here. We got one big bundle here. It is 195 kilobytes of source code. That's the stat side. It is stat size, pardon me. It is 128 kilobytes parsed, and that's after it's been bundled. And if you're running any minifiers or anything like that, that would be that size. So that's the size of the code that's going to run in the browser. And then lastly, the gzip size, 41 kilobytes, is the size that's going to be sent to the browser from your server. And then once it's unzipped, it'll run in the browser at 128 kilobytes. So each one of those numbers is important in its own way. You got this, if you hover over to the left here, you'll see that the little drawer pops out and it shows you all the size of all the different chunks that your React app output. So all in all, we got a total of 205 kilobytes of source, 135 kilobytes of process code, and 44 kilobytes gzipped. And that's just create React app out of the box, nothing else. So let's add a library and see what changes. So the library that we're going to add is called Material UI, MUI version 5. It just came out in the last month or so. It's a component library for React that comes with all kinds of really useful components to build an application quickly. Things like date pickers, charts, not so much charts. I want to say like data grid tables, little chat widgets, UI widgets, stuff that you'd see, things like this. The ability to create this, a drawer that's built into Material. Just a lot of useful components like that. Comes with its own icon library as well, and the ability to customize those. So all of that comes with a price, and that's kind of what we're going to look at today. So let's add Material UI version 5 to our library, to our project. So I'm going to close this. Again, we got an idea roughly the size of it. I'm going to close this, close the server for now, and I'm going to install, might not be able to see it over my image there. Scroll. Scroll down, move it up. So we're going to npm install @MUI/material, icons material, emotion react, and emotion styled. So maybe that's easier to see. There. Can't see it. Bear with me here. Sorry about this. I'm just trying to make it easy for you to see. There. So we're going to be running npm install @MUI/material, @MUI/icons material, @emotion/react, @emotion/styled. Emotion is a CSS, it's a styling engine that Material uses to handle its styles. And we're going to save that as a dependency, not a dev dependency, because we need all of these things running in our app. So I've just finished installing those. So now that we've installed these libraries, Emotion and MUI, let's use them. So what we're going to do is we're going to use one of the slightly more complex components. I've got the docs URL saved here. So these are the MUI version 5 official documentation. You look at the different components here. And the one that we're going to pick is the we're going to pick the speed dial. See this? Hover over it. And some little icons pop up. So I'm going to copy the code from this example, TypeScript. Copy there. Back to my app. And I'm going to create a new file inside the source directory called custom_speed_dial.tsx. Paste my code there. So we're importing a number of icons from the icon library, which we've already installed. And we've got the code for our speed dial component. I'm just going to call it custom speed dial. So now that we have it, we can use it. So inside app.tsx, I'm going to remove all of this default starter code that comes with Create React App. We don't need the CSS file or the logo either. Technically, we don't need the import for React if we're using version 17, but keep it there, doesn't hurt. And I'm going to put the custom speed dial here. And I'm going to import it. So now when we run npm run start, just to check the app, port 3000. What do we got? Oh, there it is over here. See? Why is it on the right side? I don't know, but that's okay. We got our speed dial component. Just before we go any further, why is it on the right? Position absolute, bottom, 16 pixels from the right side of the screen. Let's make it 16 pixels from the left side of the screen. There it is. Great. So now we're importing a whole component library and we're using just one of the components. So what do we think it's going to look like? Well, one component isn't very much, but it's in order to render that component, it likely needs a lot of the pieces of the library as well as the emotion styling engine. So it's going to be more than likely a bit more than you might think. So let's run a production build and see what it looks like. npx Krakow build instead of React scripts build, which will run our React config override and our Webpack analyzer plugin. Creating a production build, getting ready to open there. All right, so this time we have a much larger chunk. Remember last time our You might not be able to read it there. I can read it out, or we can look at this one. Let's go. Let's do all of them. So this chunk last time was about 200 kilobytes in source code, around 150 parsed, and around, I want to say 40 something gzipped. Now we're looking at a source size of 650 kilobytes, a parse size of 263, and a gzip size of 84. So it's significantly increased in size just to import that component. But now that we've got these pieces of the library, we can likely import other components, and it won't require additional copies of any of these. You see the speed dial itself is one of the biggest pieces of our bundle. Let's open up, let's just import a regular old button, let's say. So we're going to compare. We've got, we'll go with the, let's say the gzip size, 84 kilobytes. Get a button. Say hello. We're going to import that button from Material UI. Save that. And run the build again. Okay, so our first tab has our original build, 650, 263, 84, and with the button added, 666, 270, 86. So barely bigger at all. So now right here, what we didn't have before, we've got the button base taking up this much space in our bundle next to the much larger speed dial. But you can see it's what's called tree shaking. So it's not bringing in components that we're not using. It's dropping that code, and it's only bundling the button that we're using and the speed dial component that we're using. So what would it look like if you were to import the entire library? So we can see exactly what that looks like by using, instead of these ES6 imports, import and export commands, we can use CommonJS imports, which look like module.exports and require syntax. So what happens if I say const material equals require instead of import, and I'm going to require the entire MUI/material library. And I'm not even going to use it. I'm just going to import it, and that's it. So we were sitting at about 660 kilobytes before for the source, and around 200 and something kilobytes for the parsed, and around 80 something gzipped. Waiting for it to pop up. Here it is. All right, third one. This is with a CommonJS import of the entire MUI package. We're up to 1.96 megabytes, so more than 3 times the size. And same thing with both our parse and gzip files. So just by requiring that module, not even using it, not using any of the pieces, we've essentially bundled the entire of the material library with our app, which is not something you want to do. So there's something you can look out for. If you have syntax like this, consider if the library that you're using supports ES6 modules and use those instead, because then Webpack can shake off all the code that you're not using, and you can get a much better bundle size and a much more efficient app, which is awesome. So actually, you know what? I'm going to leave that there, because the last thing that I want to show is how to use, let's say that for some reason this library, we needed it and it didn't support any other kinds of modules. If we use anything from it, we have to use the whole thing. But maybe we don't need all of that, you know, on the homepage on every single load that the user does. Maybe this is a library that does something like provide a component for interactivity, like a date picker that only pops up if you're making a booking, or if it's something that we need on another page away from the home page, like the help page, where only a certain number of users are going to click on it. So there's no reason for us to have to load all of this huge library, this big custom speed dial, which comes packaged with the entire library. Maybe we don't want to load that by default. We only want to load it on an action, and we can actually see that happening in real time. So let's take a look at that. So what we're going to do is, with our app, instead of running custom speed dial on every load, I am going to start mixing things up a little bit. I only want to run custom speed dial after, let's say, a button has been clicked. So first we need to make a variable for the state to keep track of the state of whether we're showing the button or we're showing the speed dial. So I'm going to assume you're familiar enough with React to follow along here. Let's say show speed dial, set show speed dial. And by default, we're not going to show it. I'm going to import this from React. Okay. And that's just in case you're not sure. It's control period that I'm hitting to get the little import helper tooltip. That would be command period on a Mac, I guess. Okay. So if we do want to show the speed dial, then that's when we want to return this custom speed dial. Otherwise, we want to return, let's say, a button, and that button's going to activate showing the speed dial. So control period, import button from movie/button. This just makes it a button that looks filled in. Show, text on the button is going to be show speed dial. Okay. And then we want to actually show the speed dial when you click the button. So on click equals we're going to set show speed dial equal to true. I'm going to auto format, save it. So now what's the difference here? Is it going to wait and only run this component, only load the code in the component even when we show the speed dial? So let's find out. Yeah, sorry. npm run start, my bad. Okay, there's our button. I'm going to open up my network tab with F12. It says please wait. So I'm going to refresh and let's see what we have right now. So we have this big giant chunk, 840 kilobytes. And if we looked, that's the better part of this entire package, which includes the whole library. So we're still loading the entire library when we load our app. Now that said, it's not necessarily a good idea to test in development mode. So let's do a production build. So npm run build. So I'm just running npm run build. I'm not doing Krakow. I'm not looking for the bundle analyze. I just want to get a production build of the React app. And then I'm going to serve that and check to see whether we're loading our custom speed dial that has the entire movie library bundled with it. So I'm going to do npx serve the build directory. Serve is just an npm library, which it might actually, it's probably going to want me to install to use. Say yes. Available on localhost 3000. So now we're looking at if we run this, Refresh. We're looking at the production build instead of the development build. So I'm going to hit the refresh button and take a look. What do we get? 192 kilobytes. And that's gzipped. If we look at our app, gzip size 191. So we're still getting this huge module. So why are we getting it? Because we haven't told Webpack to actually do the code splitting. We haven't used a concept called lazy loading. So what React does is it gives you tools to only load a module when it is actually rendered by your component. So if we're looking at speed dial, even though it doesn't render the custom speed dial, it still loads the code right out of the gate when this file is processed. So that doesn't help us. What we need to do is we need to change the way that it's imported to use React's lazy loading. So we can do that with a slight change of syntax. Instead of import custom speed dial, we want custom speed dial equals react.lazy, and that is going to take a function that imports this module. So when we do that, whenever you use React's lazy loading, you also have to use what's called a suspense component. And the reason you need that is once it starts to render this custom speed dial, it's only going to start processing that file at that moment. And when that happens, there's going to be a bit of a delay before the file is ready. So at that time, React needs to know, what do you want me to show on the screen while I'm loading this import? So that's what the suspense component is for. So anything that you've imported with lazy loading, you need to wrap in a suspense component called suspense, and that just gets imported from React. Probably going to tell me in a second that it needs to import it. Yep. Import suspense from React, and it takes the one prop that it needs is something called fallback. And fallback takes a component to show on the screen while we're waiting for the custom speed dial. So what we can do, since we're using the Material UI library anyway, is we can use, that comes with a little circular progress thing. Circular progress. And since we've been importing by default this whole time, we'll continue to do that. It's the way that Material recommends that you do it on their documentation. So it's good to listen to that. So while we're waiting for the speed dial module to load, it'll show a circular progress bar. Probably not for very long, but we'll see. All right, let's save that. Let's run npm run build, create another production build, and then we'll serve the production build and see if it's any different. So the first time that we ran it, it was loading an 191 kilobyte gzip file on every page load. Let's see if this does any different, because most of that size is in the Material library that this custom speed dial component loads in the entire library. So what we're trying to do is get it so that doesn't occur unless we have an interaction event. So npx run serve, npx serve the build directory. Let's take a look. So previously, before we introduced lazy loading and suspense, we were getting 192 kilobyte JavaScript file every time we load the page. Cache is disabled. That's good. Let's refresh now and see if it's any different. So this time, we have received the biggest file that we have here is a 69 kilobyte JavaScript file instead of 191. So that seems like a pretty huge improvement. If nobody clicks that button, everyone coming to the page, you're getting less than half of the network payload that you were before. And what happens if we click the button? So I click that here, and I see some network activity has occurred. It's loaded in. There's the difference, right? 69 kilobytes, 122. You're looking at roughly 190 kilobytes, which was the entire payload that we were receiving on every load initially. So we've moved that now, so your app only loads that JavaScript whenever the click event is fired. And that's very efficient and very good. So yeah, that pretty much covers. You can run the analysis tool now and take a look at that. And what you're going to see is you're going to see two separate modules that were created. One of them that comes with the speed dial component that has the entire library packaged into it, and the other one that's just essentially the rest of the application that has the ability to run on its own. npm run Krakow build. Missing Krakow. Oh, it's because it's npx. Sorry for mixing these two up so many times in this video. In case you are getting confused by what I'm doing, I apologize. npx is a script runner. So if you've installed a package in your project that has a command line interface, for example, Krakow, npx will use it as, like a program. Krakow is a command line program. So npx says, use this program, but look for it in my node modules folder. npm can be used as a script runner by saying npm run and then the name of the script, and those scripts are found in your package JSON file right here. So if I say npm run start, it will run React script starts. npm run build, it will run React scripts build. So I am running the Krakow program, and I am running it on the build folder. Sorry, I apologize. Running the Krakow program and producing my production build with the build command. And here we have it. One giant bundle, down from 1.9 megabytes to 1.5. Parse size of 477, gzipped 122. This, which has the entire MUI library, is the bundle, the chunk that we were loading only when the button is clicked, thanks to lazy loading. And this, much smaller one, has the rest of our application with the button that we've imported using ES6 modules, so Webpack is able to extract separate from the rest of the library. This chunk loads every time we load our app. This one only loads when we click the button. And that's some tips on how you can do the same kind of thing with your actual production app. Run install Krakow and add the configuration and check out to see what modules are taking up the most space in your bundle. See if there's any way that you can introduce lazy loading to split your code into different chunks, so only certain chunks are loaded at certain times, and that way you'll have faster startup times, and everything will just be much more efficient overall. So I hope this video helped you. Thanks for sticking out the whole time, and I'll talk to you later.